Okay, the volume of a cone of radius r and height h is given by 1/3 pi r squared h if the radius and height are both increasing at a constant rate of 1/2 centimeter per second, not just r, but h2. Okay. At what rate in cubic centimeters per second is the volume increasing? Now, what rate is the volume in cubic centimeters per second? I really think it's a good idea to go ahead and write these units down here because that can help you catch some mistakes. So, specifically, when the height is 9 centimeters and the radius is 6 centimeters. Okay, so we got a ton of information for this question. Okay, so from the last problem, what did I say we're going to have to do in every one of these at some point? Okay, so unlike the proportion question, at least we know what the thing is that we need to take the derivative of this time. 1/3 pi is just a constant, so I'll leave that out front. And then, well, you don't have to have it factored out, but if you don't, you need to make sure that you have it in 2 places here. Now, my first big concern is what's the derivative of r squared h?
Oh, it's product rule.
Okay, good, product rule, because it's r squared times h. We have to do product rule. So, okay, so that's the derivative of r squared times h, left alone. 1h prime, okay.
Times r squared.
Okay, so the derivative of r with h left alone, and then the derivative of h with r left alone. Making sure that we get this chain rule piece. We took the derivative of r with respect to time, so r prime. We took the derivative of h with respect to time, so h prime. That there in blue, it's still the same product rule. So that doesn't go away. Okay, so I don't know v prime, but that's okay. That's the point of the question. So I'm going to start to plug in all of these things, and I'm going to hope that I have all this information. Okay, looks like r is 6 centimeters. R prime is 1/2 centimeters per second. H is 9 centimeters. H prime is 1/2 centimeters per second. And r squared would be 36 centimeters squared. So a ton of stuff in there. But the good news is they gave us so much information in that question that we don't have to go and find anything else. We just need to be careful in simplifying this, and then we should have our answer. So, I don't know, 2 times 6 times 1/2 times 9, what is that going to come out to? $54, because 2 times 1/2 goes to 1. 6 times 9 is 54. The units, centimeters times centimeters times centimeters over seconds. Okay, over here, 1/2 times 36 would be okay. Centimeters times centimeters squared would be centimeters cubed, and then a per second. Okay, these are exactly the same thing. These are cubic centimeters per second. These are cubic centimeters per second. So if these are like terms, we can just add them. 54 of something plus 18 of something would be, okay, 72 of that something. In this case, cubic centimeters per second. times that by a third. It's the same thing as dividing by 3. 72 divided by 3. 24? Is that right? Okay, and there's a pi. And then since I kept up with my units, I'm either going to know my answers off or I'm going to feel pretty confident about my answer. They told me in the question it's supposed to be cubic centimeters per second. And since I kept with my units, I've got cubic centimeters per second. So that makes me pretty confident in my answer. If my answers had some other units, then I would know I had forgotten something. Okay, so you got what you needed out of that one? Anybody else that was going to ask about number 1 have a follow-up question to that? Okay, I just want to highlight here. I think the most common mistakes here is what is in blue. Product rule, you got to be careful with that.